Hello everyone, my name is S.N. Patil, NYNC College, Chhattisgarh. This is the third lecture of coordinate geometry. In previous first two lecture, we discussed the change of axis, in which we discuss translation and rotation. That is, translation means what? We shift the origin, and the rotation, we rotate the axis. Okay. Now, in this lecture, we discuss the same 2 points. The first point is translation. The second point is rotation. Translation means we shift the origin, and rotation means we rotate the axis here for the conic. Means which is either circle, ellipse, hyperbola, or parabola. Okay. So first we discuss the conic. What is the conic? See, in the first diagram, when the plane through the cone vertex only, then which is called as a point. Okay. In the second diagram, when the plane passes through the vertex and touches the cone, the section is a tangent to cone. Now this is the tangent to the cone, and here tangent to the cone. Okay. Now when the plane intersecting, means there are number of lines formed here as like generator. Okay. Through the vertex and intersect the cone, then the section is a pair of intersecting line. All lines are the intersecting in this. Okay. So next, if a plane is perpendicular to axis of the cone and cuts the section is a circle. See, all the lines perpendicular to this plane. Okay, that time it form a circle. This is the circle, the common intersecting part of plane and conic, that is the circle. Second, if the plane oblique to the axis, this is oblique, the cone on one side of the vertex, then the section is a ellipse. So this is ellipse. Next, if the plane is parallel to the generator of the cone, the section is a parabola. And if the plane is parallel to the axis of the cone, then the section is a hyperbola. Okay, so this is the different part of the conic. Now next, so this is the diagram: parabola, circle, ellipse. Now some important definition. The first one is conic. Conic is defined as the locus of point which moves in a plane such that the ratio of its distance from a fixed point in the plane and its perpendicular distance from a fixed straight line is a constant. Suppose we have the suppose this is the directrix and this is the fixed point. The fixed point we call as a focus. Okay, and this is a P, be any point. Okay, moving point in the plane. Then this P point, P to S, and this P point, its distance perpendicular to the directrix. Okay, suppose this is a M point. Then the ratio P to S with P to M, it should be a constant. That is the conic, whatever the figure form. Okay, that is the conic. The fixed point in the plane is called the focus. Now this is the fixed point. Okay, which is called as a focus, and it is denoted by S. Directrix, the fixed straight line. Now this is the directrix. The fixed straight line is called the directrix of the conic. It is denoted by the D. Eccentricity, the constant ratio, whatever the ratio, P to S with P to M, the ratio is called as a eccentricity of conic. It is denoted by E. Okay. Now compare this E with 1. If the value of E is equal to 1, the conic is called parabola. If less than 1, value of E is less than 1, the conic is called ellipse. If greater than 1, the conic is called hyperbola. Okay. Now let us prove equation of conic. First we consider the diagram in which this is the directrix D. This is the directrix. Okay. This is a S point. S means what? Fixed point. Okay. And P be any point. P be any point in the plane. We mention the point of S here. The S is x1 comma y1, and for P x dash y dash. Okay. Fixed point. Yes, that is the focus. P be any point in the plane. Okay. D is this is the directrix. Having equation is, this is the straight line. The equation of the line is ax plus by plus c is equal to 0. Okay. Let S be a fixed point having coordinate x1 comma y1. D be the directrix ax plus by plus c. P be any point in the plane. Now from figure, the PM is perpendicular to the directrix. Now the ratio length of PS with length of PM, which is constant and which is denoted by the E. E means eccentricity. Now here length of PS we calculate using the distance formula. Okay, so we calculate length of PS as a distance formula, square root of say P to S. That is length of PS is equal to x dash minus x suffix 1 bracket square y dash minus y suffix 1 bracket square. Okay, this is the length of PS. Similarly, we calculate the length of PM. Okay, we know the formula. Suppose we have the plane. See, this is the plane. Okay, and this is the perpendicular line to the plane. Suppose the equation of the plane is ax plus by plus c, and this is the P point. Okay, we consider same diagram, P point, and which is passing through the point x dash y dash. Then perpendicular length we obtain by the formula mod of. So here in the equation of the plane we put this point, that is ax dash plus by dash plus c divided by under root the coefficient square a square plus b square. So this is the perpendicular distance P to M. Okay, put this value here and squaring both sides, then we get this kind of the equation: x dash minus x1 bracket square plus y dash minus y1 bracket square. Okay, and when we squaring it, then square root and square cancel, the simple term is remaining. Now here E square and length of PM. See, this is the length of PM. Okay, and we squaring this, the square of the numerator and in denominator, square and square root cancel, simply a square plus b square term is remaining. Okay, after simplifying this, now the simplifying the equation locus, the locus of the P, that is the instead of x dash y dash we write the x. The P is moving point, that's why we write x, simply x and y, that is x minus x1 bracket square plus y minus y1 bracket square is equal to E square in bracket ax plus by plus c bracket square divided by a square plus v square. Okay, now after simplify this, we get the second degree equation in x and y. That is the general equation of the second degree after simplify. we get ax square plus twice hxy plus by square plus twice gx plus twice fy plus c. Okay, so this is general equation of the second degree. Now here we discuss the, from this equation we discuss the conic also. The after calculating the value of a, b, c, h, g, f, that is the discriminant. The here we calculate the discriminant a square minus ab. If here 2 is absent, then take here the accordingly value. Okay, now compare this value with 0. We compare the e with 1. Similarly, compare the a square, means the discriminant, with 0. If this value is equal to 0, a square minus ab is 0, then the equation 1 is called as a parabola. If this value is negative, then ellipse, and greater than means positive, then parabola. See, if a square minus ab is negative, means less than 0, then equation 1 is called an ellipse. And if positive, a square minus ab is strictly greater than 0, that is the hyperbola. Okay. Now, if a is equal to b, the coefficient of x square and coefficient of y square is same, and provided the condition abc plus twice fjs minus af square plus minus bg square minus ch square is non-zero. Okay, means this condition is provided for all the cases. Okay, now next, see, this is the general second degree equation of the conic. Now we discuss the first rotation. Now we rotate the conic. Means what? See, we discuss the 2 point here, the rotation and the shifting. The first we right now discuss the rotation. Means what? Shifting and rotation. So for rotation, we consider the equation of rotation. That is x is equal to x dash cos of theta minus y dash sine theta. Y is equal to x dash sine of theta minus y dash, sorry, plus y dash cos of theta. So using this equation, we find out the standard form of the conic. Okay, let us see. Every general equation of the second degree in x and y represent the conic. That is, the equation is ax square plus twice hxy plus by square plus twice gx plus twice fy plus c is equal to 0. This is the general equation of the second degree, and which is what represent the conic. Now here we just discuss the condition. The condition what? The for parabola, ellipse, hyperbola, and circle, when this from secondary, when this form, when the provided abc plus twice fgs minus af square minus bg square minus ch square, it should be a non-zero. Suppose this value is delta, it should be a non-zero. If which is 0, that time the equation 1 become a straight line. Okay, so we must have this condition is non-zero. Okay, this is non-zero. Now we consider this is the non-zero. Delta is non-zero. Now we take the equation of rotation. That is, we rotate the coordinate axis through an angle theta. The equation of rotation are, we just discussed, x is equal to x dash cos theta minus y dash sine theta. Y is equal to x dash sine theta plus y dash cos of theta. Put these two equation in equation number 1. Substitute here. Then equation 1 become a into x square, that is the value of x, twice x into y, value of x and y. So here substitute value of x and y throughout, we get the equation. Now in this equation means when we rotate the conic, then the requirement is theta. Without theta, we can't rotate the conic. So for finding the theta, we equate the coefficient of x dash and y dash, the coefficient of x dash and y dash, we equate to the 0. It means what? This term x dash y dash term become a 0 in the equation number 2. Now after simplifying this, we identify the coefficient of x dash y dash, which is minus twice a sine theta cos theta plus twice h in bracket cos square minus sine square plus twice b sine theta cos theta is equal to 0. Now from first and last term, first and third term, where 2 times sine theta cos theta is common, and we know 2 times sine theta cos of theta is equal to sine of 2 theta, and we know the bracket is cos square theta minus sine square theta is equal to cos of theta. Now simplify this. So here we take sine 2 theta is common and minus side is common, that is a minus b, and twice h cos of 2 theta. Now put this term in right hand side, and cos 2 theta is divided and a minus b is divided, then we get tan of 2 theta is equal to twice h divided by a minus b. Okay, so in this way we calculate the theta, that is theta is equal to 1 by 2 tan inverse twice h a minus ab. Otherwise, from given value we calculate it. Okay, now here the coefficient of x dash y dash is 0. The equation is free from the term x into y. Now similarly here the x dash, see here first bracket, it's square. Similarly we construct the x dash square term. So what is x dash square term here? Here a into cos square theta. Now here x dash into x dash square, the coefficient is twice h cos theta into sin theta, Okay, now here what is the coefficient of x dash here? That is b sin square theta. Okay, now the whole term we consider as a capital A. Okay, similarly we construct the y dash square, we construct the x dash y dash, then the equation 1 we write as a capital Ax dash square plus capital By dash square plus twice Gx dash plus twice Fy dash plus C. Okay, so this is the equation when we rotate the conic. Now here discuss the some cases. The first case, when value a is equal to b, and here x into y is absent, then definitely it becomes a circle. Okay, in case number 1. Okay, then equation 4 become a circle. Now the second case is a is not is equal to b, and both should be a non-zero. Then equation 4, it become an ellipse. Okay, now see, so here we construct the x dash related term first, and then we construct the y dash related term. Now in which we take a is common, here b is common. Now we consider the bracket. Now bracket is as like a square plus twice ab. Okay, a square plus twice ab in bracket term. If we add here b square and subtract the b square, then first three term what represent, which is perfect square, a plus b bracket square. Okay, so this is a plus twice ab. So accordingly identify the b. B is here g upon a, that is we add here g square plus a square and minus g square upon a square. Similarly here b is f upon b, then we add f square divided by b square and subtract f square divided by b square. Okay, in this way we adjust the term, then we get the perfect square. See here, we add here, then we subtract here. We add here and then we subtract here. Okay, now bracket is perfect square. Bracket is perfect square. Okay, bracket is perfect square. Now here, this is the shifted the origin of the ellipse. Okay, but some condition is here. Now we discuss the condition. Now this is the shifted point. Okay, and we consider the bracket, the capital X we consider as a x dash plus g upon a, and capital Y as a y dash plus f upon p. F upon p. Okay. Now, some cases we discuss here. If this value is k is 0, k is 0, then either we get the straight line or imaginary number, depend on the sign of a and b. Suppose b is negative, b is negative and a is positive, then which is straight line. If a and b having same sign, then definitely which is imaginary value. Okay. Now next case is k is not 0. If k is not 0, then we divide throughout k, then we get right hand side is 1, and which represent the ellipse. Okay, we divide the k. Now it can be written as x square upon k upon a plus y square upon k upon b is equal to 1. Okay, it represents a hyperbola. Okay, it represents the ellipse, and the next one is if it represents the hyperbola having the opposite sign. Okay, if same sign, then ellipse. Okay, now next, suppose a is 0 and b is not 0. A is 0, b is not 0, means what? We get the quadratic. Now the equation number 4, we discuss the equation number 4 and its cases. The first case we discuss a is equal to b, we get the ellipse. Okay, and also we get the hyperbola if the k upon a and k upon b having the opposite sign. Now the case number 3 we get, if we consider a is 0 and b is non-zero, then this is the quadratic equation for y dash. Same case for we consider b is 0 and a is non-zero, then we get the quadratic equation for x dash. And if quadratic is there, then definitely quadratic equation is represent the parabola. Let's see how. A is 0, b is not is equal to 0, then the equation is quadratic in y dash. Now we again apply the same process. We make it perfect square. We adjust the sum term. Okay, b is common. Accordingly, we adjust the term. Now this is the perfect square. Okay. Now the shifted, which is shifted at the origin. Okay. So what it represent? It represent the parabola. So for first we write the simplified form as we write in a previous case number 2. We write this is the capital Y, and we write this term as a capital X. So what we get? Y double dash b is equal to y double dash minus twice g x double dash. Okay, means what? Y double dash is equal to we consider y dash plus f upon b. Similarly, x double dash is equal to the value as a x dash plus c upon 2g minus f square twice bg in this way. So this is represent the parabola. Okay. Now next case is vice versa, means b is b is 0 and a is non-zero. Okay, again it represents the parabola. Okay, so this is the case we discuss about the rotation, where we consider the equation of rotation, and we get the standard form in which we discuss the conic, first circle, second ellipse, parabola, and then first circle, second ellipse, third is ellipse, parabola, fourth is parabola. Okay. Now next is shifting. Next is shifting. For that we consider the translation equation. Okay, consider the general equation first. General equation, and we shifted the origin at x1, y1. Okay, then equation, these are the equation of translation. Now put the value of x and y in equation number 1. Okay, now simplify. This is as like a plus b bracket square. This is c plus a plus b into c plus d. Now simplify the whole equation and construct the value of capital X, capital XY, capital Y square. Okay, then construct the x suffix 1, y suffix 1. So we get, see, I'm constructing first capital X square. Okay, now capital X is common, capital Y is common. So in this way we get the equation. Okay, now here the conic is now at the origin. The coefficient of first degree term means the coefficient of x and y must be 0. That is the bracket. The bracket means ax1 plus hy1 plus g is 0. Okay, similarly second. Now from equation 3 and 4, when we solve it using the known method, using known method means you can solve simultaneously also, otherwise using Cramer's rule also. Now suppose, now I am applying the Cramer's rule. Okay, Cramer's rule. The Cramer's rule is x1 upon the coefficient of y1 and the constant, that is h, b, g, f, minus y1 the coefficient of x1, a, h, and the constant g, f, and the constant, it can be written as 1 upon the coefficient of x1, y1, that is ah, h, p. We get x1 upon h into f minus bg is equal to minus y1 upon a into f minus h into g, and 1 upon ab minus a square. So here take minus sign is common in denominator. Minus sign is cancelled. That is, it becomes hg minus af. In this way, we get, for calculating x1, consider the first and last equation, and for calculating y1, consider second and last equation. So we get x1 is equal to and y1 is equal to. Okay. Now this is the center of the conic. Now in which we discuss the case value of the AB minus A square. If this value is 0, then then what will represent this? It means what? The center of the parabola, this is a quadratic equation, is at infinity. And if the both AB minus A square and HF minus BG, both are the 0. Okay, both are the 0. Then the center is indeterminate and the conic reduced to a pair of parallel lines. Okay. So we discussed the 2-point rotation and translation. Now let us solve the example on the. Let us solve the problem on the conic. Question is, find the center of the following conics and identify them. Okay, here is equal to 0. Now this is the second degree equation, definitely, which is either circle, ellipse, hyperbola, or parabola. Okay, so for that, first we write given equation. Let 3x square minus 10xy plus 3y square plus 14x minus 2y plus 3 is equal to 0. Now consider the general secondary equation, which is ax square plus twice hxy plus by square plus twice gx plus twice fy. This is small g, fy plus c is equal to 0. Now compare 1 and 2. Then we identify the value of a is 3. That is the coefficient of x square. Now the coefficient of x into y is, in equation number 1 is minus 10, and then equation number 2 is twice h. So we get the value of h. 2 is divided here is minus 5. That is h is equal to minus 5. Now the coefficient of y square is b, and here 3. The coefficient of x, twice g is equal to 14. That is g is equal to 7. Similarly here twice f is equal to minus 2. That is f is equal to minus 1, and c is equal to 3. Okay, so first we identify the center of the conic. The formula of center is h. What is the formula? H into f, minus b into g divided by ab minus h square. Okay. Second is g into h minus a into f divided by same denominator, ab minus h square. Okay. Now simplify the value, that is h into f minus b into g. The value of h is minus 5, value of f is minus 1, minus value of b is 3, value of g is 7. Okay, that is plus 5 minus 21. Okay, that is minus 16. We get minus 16 divided by a into b minus h square. The value of a is 3, value of b is 3, value of h is minus 5, its square, that is 9. Okay, minus 25. 9 minus 25 is minus 16. Minus 16. Okay, comma. Now g into h minus af is equal to g into h. The value of g is 7, value of h is minus 5, a into f, a is 3, f is minus 1. Okay, that is minus 35, and minus plus 3, minus 32. Minus 32 divided by ab minus a square is calculated, that is minus 16. So we get center is equal to minus plus 16 is cancelled, and minus cancel, that is 1 by 2 is center of the conic. Now identify. So for identification, what is the value of AB minus A square? AB minus A square. The value of AB minus A square is minus 16. Okay. Now, but the actual formula The actual formula is a square minus ab. A square minus ab. Okay. So here multiplied throughout minus sign, then we get the plus 16, and which is what? Strictly greater than 0. It represents what? Hyperbola. Okay. Now similarly, we calculate second problem. The second, let 14x square minus 4xy plus 11y square minus 44x minus 58y plus 71 is equal to 0. Say equation number 1, and general equation is ax square plus twice hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Compare 1 and 2. The coefficient of x square is a. The coefficient of x into y, that is h, is equal to twice h is equal to minus 4, that is h is equal to minus 2. Coefficient of y square, the coefficient of x, twice g is equal to minus 44, that is g is equal to minus 22. Twice f, see, twice f is equal to minus 58, minus 58. Then minus sign keep as it is. Then f is equal to 29, and the minus sign. Okay, and the c is equal to 71. Okay, now the center of the conic. Center of the conic HF minus BG. Center of the conic HF minus BG divided by AB minus A square, comma GH minus AF. GH minus AF divided by AB minus H square. Okay. Now let us find the value of H into F. H into F minus B into G is equal to, the value of H is minus 2, value of F is minus 29, minus B into G, the value of B is 11, and G is minus 22. Okay, now minus plus 29 into 2, that is 58. Now here 11 into 22, 11 into 22, that is 242, and this minus plus 242 and plus 58. So we get, now this is 8 plus 2, 0. Okay, 0, and here 1, that is again 0 and 1. 2 plus 1 is 3. 300. Now calculate AB minus H square. AB minus H square. AB is A into B, 14 into 11, minus the value of H. Value of H is minus 2. Minus 2. That is 14 into 11. 14 into 11. 5 and this 1. 154 minus 2, minus 2 square is plus 4. Okay, so we get what? 150. Now next requirement is GH minus AF. G means minus 22. H minus 2 minus A means A is 14 F. F is minus 29. Okay. We get here minus minus plus 44. Now this minus minus plus. Okay. Now 29 into 29 into 14, and this plus. Okay. That is 9 6 6 14 0. That is 406 406 plus 44 plus 44 4 plus 6 0. Okay. Now 4 and plus 1 5 450. Now substitute here, that is center is equal to 300 divided by AB minus A square means 150 comma 450 divided by 150. So here 0 cancel, 15 into 2 30, that is 2 is here, 0 cancel, 15 into 3, okay, 2 comma 3. Now this is the center. Now we identify which conic is exists here. So for that, now we already calculate AB minus A square, okay, which is 300, but we want identification, we want A square minus AB. So multiplied minus sign minus 300, and which is negative value. The given conic is an ellipse, and ellipse. Okay. Thank you.